Hello, welcome to my channel. Let's discuss indices. What is indices in mathematics? Let's assume a number a is raised to power x. This x is the index, the plural being indices, while the number itself is known as the base. Okay, therefore, indices is the number of time a number multiply itself. There are different rules of evaluating numbers with indices. Let's talk about the different rules of indices. Rule number one: when you have a number a raised to power x and that same number multiply itself raised to power y, this can be evaluated as a raised to power x plus y. Let's look at an example. 2 raised to power 2 times 2 raised to power 3 will be equals to 2 raised to power these 2 because they are multiplying each other. The power will be added 2 3. Okay, so this is evaluated as 2 raised to power this plus this, which is equals to 2 raised to power 5. That is rule number one. Rule number two: if a raised to power x divided by a raised to power y, this can be evaluated as a raised to power x minus y. For example, if you say 2 raised to power 3 divided by 2 raised to power 2, this will be equals to 2 raised to power 3 minus 2, which is equals to 2 raised to power 1, which is equals to 2. That's the second rule. Let's look at another rule. Number three: if you have a number a raised to power x and the expression itself again is raised to power y, this can be evaluated as a raised to power x times y. Let's look at an example. If 2 raised to power 2 bracket raised to power 3, this will be equals to 2 raised to power 2 times 3, and that will be equals to what? 2 raised to power 2 times 3 is 6. So this is how you evaluate this kind of expression. Let's look at another rule of indices. Now we've talked about three rules of indices. Let's look at rule number 4. Rule number 4: if you have a number x raised to power negative of a. This can be evaluated as 1. This minus will become 1 over. Okay? The minus here in this power will become 1 over. Then you bring down this x as the denominator raised to power a. Okay? Let's look at an example. Example, if you have 2 raised to power minus 3, this will be equals to, like I told you before, this minus will become 1 over. Then the 2, you bring it down, and then the minus disappear because it is the minus that become 1 over. So this will be equals to 1 all over 8. Okay? Let's look at another rule. Number 5. If you have a number x that is raised to power a all over b, this can be expressed as, you see this numerator will be the power, and this b will be the root of this number. So this can be expressed as the b root, okay, of x, the number, raised to power a. Okay, this division become the b root of the number, okay, raised to power a, which can also be expressed as the b root of x, can also be expressed like this, raised to power a. Let's look at an example. If you have a number 2, or let's say this time around, let me use another number to make it easy for us to understand. Let's say a number, let's say 4 raised to power 3 all over 2. This will be the square root of 4, okay, raised to power 3. But don't forget that in mathematics, we don't usually, if this is second root of a number, that is square root, we don't put these two there. I just put it there for you to understand what the role of these two will be. So this will be equals to 2 raised to power 3, which is equals to 8. Let's look at another example of this. Let me use, okay, this time around, let me use 9 raised to power 2 all over 3. Okay, this can be expressed as the cube root. Let's say 27 raised to power 2 all over 3. This will be equals to the cube root of 27, okay, raised to power 2, which will be equals to what? 3 raised to power 2, which is equals to 9. Okay, now let's look at another rule. Rule number 6. Let's say a number x raised to power 0. This will be equals to 1. Any number raised to power 0 is equals to now is any number raised to power 0 is equals to 1, provided that that number is not equals to 0. If the number is equals to 0, if x is equals to 0, then x raised to power 0 will be equals to 0. Okay, meaning that any number raised to power 0 is equals to 1, provided that that number is not equals to 0. If the number is equals to 0, then x raised to power 0 is equals to 0. Now, having gone through all the rules of indices, let's now do some exercises. The exercise number 1 is, let's simplify this expression. 5y times 4y raised to power 4. Let's look at it. You know, this can be expressed as 5 times y times 4 times y raised to power 4. Let's put the like terms close to each other. Let's bring this 4 here. This can be written as 5 times 4. This 4 come here now. Times this y times this y raised to power 4. Right? And we know that this is equals to 20 times y raised to power 4. Okay. Using the rule of indices, which we first stated, the first rule, this y times y raised to power 4 will make the expression to be equal to 20 times y raised to power the 1 here. You know there is 1 here, it's just that it's not written there, right? Good. 1 plus this power 4, and this will be equals to 20y raised to power 5. This is the answer. Okay, let's look at another example. This one is simple. M raised to power 8 divided by m raised to power 5. Let's simplify. I believe this should be easy for you to do, as this will be the same thing as m raised to power 8, this power, because they are dividing each other. That will be minus, okay, this power, which is 5, and this will be equals to m raised to power 3. Okay, another example. Another exercise number 3. Let's say 24 x raised to power 6 divided by 8 x raised to power 4. Let's see how we can do this. Let's simplify. 24 x raised to power 6 divided by 8x raised to power 4. 8 here is 1, 8 here is 3. Now we have 3x raised to power 6 divided by x raised to power 4. And we know that this is the same thing as 3 times x raised to power 6 divided by x raised to power 4, which will be equals to 3 times x raised to power 6, which is this power. Because they are dividing each other, that will be minus 4, right? And that will be equals to 3 times x raised to power 2, which is equals to 3x raised to power 2, right? This is the answer. Okay, let's look at exercise number 4. Simplify. 9a raised to power minus 5 times, this is a plus 5a raised to power 6. Let's simplify this. We know that this is the same thing as 9 times a raised to power minus 5 times 5 times a raised to power 6. Okay, so this is the same thing as 9 times 5 times, we just collect the like terms. This one come to this side. Okay, then a raised to power minus 5 times a raised to power 6, right? And we know this is equals to 9 times 5 is equals to 45, right? Times a raised to power minus 5, okay? Because they are multiplying each other, their power will be added together, plus this, the power here, 6, which is equals to 45 times a raised to power minus 5 plus 6, a depth of 5 with 6 in pocket, that will be 1. So this is equals to 45a. This is the answer. Let's look at another exercise. Number 5. Minus c squared times c raised to power 4 divided by minus c raised to power 5. Let's look at it together. Okay, this can be rewritten as this. We know that this minus c is the owner of this squared, and this will become plus c, right, squared times 4 times c raised to power 4 all over minus c raised to power of 5. And because this is odd number, if we say minus times minus 5 times, minus times minus is plus, times minus is minus, times minus is plus, times minus is minus, meaning that this will later result into minus, okay, which will be equals to c squared times c raised to power 4 divided by minus c raised to power 5. Okay? And this can be written as minus, okay, c raised to power 2 times c raised to power 4 divided by c raised to power 5. Okay? Now, this will be same thing as c raised to power 2. Because of these times, we are going to add the power, which is 4. And because of this division, we are going to subtract minus this power, which is 5. And this is equals to c raised to power 6 minus 5. And this will be equals to c raised to power 1, which is equals to c. That's the final answer. Let's look at another example. Example number 6. 25a raised to power 2, all brackets 1 all over 2. Let's simplify this. To make it easier for us, let's break it down. We know that this is 25. It's the same thing as 25 times a raised to power 2, everything in brackets, 1 all over 2. Okay? Now, from the rules of indices, this is the same thing as 25 raised to power 1 over 2 times a squared raised to power 1 over 2. Okay? So, from the rule of indices, we know this one will be equals to the square root. Don't forget that 2 is there, but we don't write it there in mathematics, right? Good. Square root of 25, okay, times a raised to power 2 times 1 all over 2. Okay, 2 here 1, 2 here 1. So this will be equals to root of 25 is 5 times a raised to power 1, which is equals to 5a. This is the final answer. Good. Let's look at another one. Number 7. 4 raised to power 1.5 cube root. Let's simplify this. We know that from the rule of indices that this will be equals to 4 raised to power 1.5 divided by 3. Because in indices, if you have a number like this, a raised to power x over y is, this is equals to y root of a raised to power x. So we just reverse this. That's how we got this. Okay. So if we simplify this, 1.5 here 1, 1.5 here 2, this will be equals to 4 raised to power 1 over 2. And from the rule of indices, like this one, this is the same thing as square root of 4, which is equals to 2. This is the final answer. Let's look at number 8. which is 2x raised to power 1 over 2 times 2x raised to power 3, everything raised to power 3 over 2. Let's simplify this. This is the same thing as 2 times x raised to power 1 over 2 times 2 times x raised to power 3, everything raised to power 3 over 2. And we can simplify this further to be 2 raised to power 1 over 2 times x raised to power 1 over 2 times 2 raised to power 3 over 2, this one, then times x raised to power 3, okay, times 3 over 2, okay. Don't forget that all these ones, they have 1 as their power, okay. So this one just mean 1 times, we just didn't write it there because to not have much effect. 1 times, okay. And this will be equals to 2 raised to power 1 over 2 times x raised to power 1 over 2 times 2 raised to power 3 over 2 times x raised to power 3 times 3 over 2, which is 9 all over 2. Okay, let's collect like terms so that it will be easy for us to evaluate. 2 raised to power 1 over 2 times, let's bring this one here, 2 raised to power 3 over 2 times x raised to power 1 over 2 times x raised to power 9 all over 2. If we evaluate this will be, we'll put plus here, okay, and this one too will put plus, okay. This is equals to 2 raised to power 4 over 2 times x raised to power 10 over 2. You may wonder why it is like this. If you say 1 over 2 plus 3 over 2, get the LCM, which is 2. 2 here 1, 2 times 1, 1 plus 2 here 1 times 3, 3 is equals to 4 all over 2. Okay, that's how why this one is 4 over 2. And also this one, this 1 over 2 plus 9 over 2 over 2. The same way, get the LCM, 2 here 1, 1 times 1, 1 plus 2 here 1, 1 times 9, 9 equals to 10 all over 2. Okay, so this 2 here 1, 2 here 2, 2 here 1, 2 here 5. Okay, so this is equals to 4 times x raised to power 5, which is equals to 4x raised to power 5. And this is the final answer. If you love this video, if you enjoy it, kindly like, click the like button, subscribe to my channel, and share for others to benefit. After subscribing to my channel, you see a bell symbol. Click the bell symbol for you to be notified when I make new videos. Thank you very much till I see you in my next video. Bye bye and take care.